In this video, we will talk about Saga Design Pattern for data consistency in microservice architecture. We will go through a simple use case of online purchase of stock and look at why Saga Design Pattern to be used, different implementations of Saga Design Pattern, advantage and disadvantage of Saga Design Pattern with the help of this use case. So let's begin. Here we have 4 microservice: application 1, application 2, application 3 and application 4, and each of these microservices has dedicated DB. So we are talking about online purchase of stock. So let's say application 1 is the UI service, application 2 is the stock service, application 3 is the payment service, and application 4 is the feedback service, which gives you either the purchase of stock is done successful or not. So as a user, when go for purchase of stock, the request first goes through UI service, and at the UI service request for selection of stock. So the request move forward to application 2 or stock service, and stock is selected, and depending upon the trading day and at the value of the stock, user go for the payment of the stock. So the request move forward to payment service. At the payment service, there are two scenarios possible: either successful transaction or decline of the transaction due to any reason. So the request in both the scenario will move forward to the feedback service. If the transaction is successful or the transaction is failure, both kind of situation should be notified to the user. So from feedback service, the user will get the response on the UI service whether the transaction is successful or not. So if you look at this simple use case scenario, we have 4 microservices and a single use case of purchase of a stock. The request is going through different microservices and involving data of different microservices. So let's note down a few points related to such scenario that we experience in our real life. So here you can see a single request is spanning over multiple services. So when a single request span over multiple services, need for atomicity of the transaction and isolation of concurrent transactions is required. By the term atomicity of transaction means the local transaction could either be successful or should not happen. Means if the transaction is failure, it would require to be rollback. By the term isolation of concurrent transaction means it may happen a situation like user is logging via laptop, user is logging via app, and from both the devices user is trying to purchase the same stock or maybe different stocks. Next point, the transient state of request process between services. As we have discussed earlier, at the payment service, let's imagine the transaction is going on, money is deducted, but due to some reason transaction comes to failure. So in this case, your money is deducted but transaction is still showing failure. If the transaction is failure, the amount that is deducted should be returned back to the user. So this transient state of request process between services need to be persisted in case of failure also. Moreover, in case of failure, there should be a rollback or compensating action. So if you look at these points, they all is related with data inconsistency. So in order to maintain data consistency, we use Saga Design Pattern. So moving further, we will look at the basics of Saga Design Pattern and what is called Saga. In a simple layman term, Saga is nothing but sequence of local transaction. So as you have seen earlier, the request for the purchase of online stock is going through 4 of the microservice. So all the combination of those local transactions is called Saga. In Saga Design Pattern, we have each transaction to a particular service is treated as local transaction. So we have sequence of local transactions and each local transaction updates data within a single service. Transaction could be sequential or parallel. By the term sequential or parallel means it could be synchronous or asynchronous. This design pattern preferred for long-running transaction. So if you have only 2 of the microservice or 3 of the microservice, Saga design pattern is not a preferable approach. So in case your request is going through 5 microservice, 10 microservice, then for data consistency, you can give a look to the Saga design pattern. Now there are different approaches for implementation of Saga design pattern, but mostly 2 are used. So talking about them, first is event-based approach and second is orchestration-based approach. So we will look at both of the approaches coming down. So event-based approach is also called choreography-based approach. Again, if we look at the same use case, that is of online purchase of a stock. So we have UI service, stock service, payment service and feedback service. In case of event-based approach, each of the microservice generates an event and another microservice listen to that event and perform action based on the event generation. So again here, when a user try to purchase the stock, it will first go through the UI service. The UI service here, in case of event-based approach implementation, generate an event called selection of a stock, and the stock service listen to this event. So on listening of this event, the stock is selected and it will further generate do payment event. Now the payment service will listen to the do payment event, and after the successful or the failure of the payment service will generate a payment confirmation event. So this payment confirmation event will contain either success or failure. Now the feedback service will listen to this payment confirmation event, and the feedback service generates an event called stock purchased or failure. In case of successful, it is stock purchased. In case of failure, it will be stock not purchased or something like that. And finally, the UI service will listen to the feedback service. Now here simply there is one-to-one relation between event and the microservice. It may happen that one of your microservices is creating an event and multiple microservices are listening to that event. It may kind of create a cyclic dependency between the microservice. So this could be a disadvantage of event or choreography based approach. So let's talk about the few points of event or choreography based approach. So in generally, events are domain based. So here select stock do payment, payment confirmation and stock purchased, all are events, and these events, if you see, are based on the business of the microservice. For example, If it is payment service, it is generating payment confirmation event, and this payment confirmation event is containing either success or failure message. So each local transaction on successful completion publishes domain event that in turn triggers local transaction in next services. So here we are talking about one-to-one relationship. It could be one-to-many relationship also. The next service could be single or multiple also, depending upon the business use case. At last, local transaction, distributed transaction ends. So these are the points related to event or choreography based approach. Now let's suppose what happens if there is a failure in case of event or choreography based approach. Let's look at that scenario. In case of failure of the transaction, we prepare for rollback or compensating action. But remember, rollback and compensating both are different terms. By the term rollback, we mean we are trying to revert the transaction as if it had never happened. But in case of compensating, we are admitting that a transaction has happened and it has failed, and we are trying to do something else to compensate that transaction. So let's assume here at the payment service your money is deducted, but due to some reason the transaction failed. So the payment service will generate an event called payment failed. Now as the money has been deducted from your account and the payment is also getting failed as an event, right? So in order to compensate this action, this event should be listened by feedback service and by the payment service in order to revert the deducted amount. So the payment failed event will listened by the payment service that will return or refund to the client or any other microservice that is doing this process, and simultaneously by the feedback service that payment has failed. So on receipt of payment failed event by the feedback service will generate an event. So the event could be stock purchase failed that will be listened by user service or the UI service, and the response is finally shown to the user. Let's talk about orchestration based or command based approach for Saga Design Pattern. In orchestration or command based approach, the microservices do not directly interact with each other. Instead of that, we have a common orchestrator to perform such action. So again, taking the same case of online stock purchase. So the user hits the request for online purchase of stock. It will go through UI service. UI service will generate a command buy stock. Now the buy stock, instead of directly going through a stock service, will go through a central orchestrator. So the orchestrator on receiving of buy stock will generate the command select stock, and this select stock will be listened by the stock service, and the stock service will reply with a next command saying stock selected, and again this will go to the orchestrator. Upon receiving of stock selected command or reply, orchestrator will further generate another command saying do payment, and it will be listened by your payment service. Now the payment service will process the payment transaction, and upon successful or failure of the transaction, it will generate a reply. So let's say payment confirmation. If the payment is success, and this reply will be listened by the orchestrator, and upon receiving of this reply, orchestrator will further generate next command for the feedback service payment done. So this payment done will be listened by feedback service, and the feedback service reply to the orchestrator. If the payment is successful, then stock purchased, and the orchestrator again will reply to the UI service that the stock is purchased, and it will be shown to the user screen. So if you look at an orchestrator based approach, there is a central orchestrator. So this orchestrator is an additional service that we have implemented apart from the stock purchase architecture. So this is an extra overhead in case we are going to implement orchestrator or command based. So you can take this as a disadvantage of this approach also. Here you are increasing the complexity of the architecture. So if we talk about the implementation of orchestrator, it could be a orchestrating tool like Camunda, or you can use finite state machine in Java to build this orchestrator. Now let's talk about compensating action, how it could be done in orchestration or command-based approach. Let's assume instead of payment confirmation, stock purchase and payment done, so remove all these points, we have payment failed, the same use case that we have looked in event-based approach. So payment service will reply to the orchestrator that the payment has failed. Now the orchestrator, after receipt of payment failure, generate command to the feedback service that payment is failure, and the feedback service will return the reply stock purchased fail, and this will go to the orchestrator, and further orchestrator also will generate the command initiate refund. So this refund command could be either listened by the payment service or any other microservice where logic of refund is written, and the reply will be sent back to the user. So let's move ahead for Saga Design Pattern. Till now we have talked about event-based approach or orchestration-based approach and the compensating action in case of failure of transaction in both the approaches. But what if compensating action itself fails? So we will look at this use case where compensating action itself failing. So remove all the unwanted part from here. We have a simple use case of failure. You are doing the payment service has deducted the money but generated payment failed. Now the orchestrator has initiated the refund. Let's suppose this initiation of refund failed. So you may have encountered this situation where you are paying the money through some bank account to other bank account. The money got deducted from your account and the bank is saying it will take 3 to 4 working days to get the refund or to credit the amount in other person's account. So here we can have a retry mechanism that we can implement if we are implementing microservice with the help of Spring Boot. Again, there should be limitations on the number of retry. Let's say we have limitation of 3 by the business. So again, after retry limitation reached and it is failing again, there is only one thing we can do, or we can try to do, that is store the state of the transaction maybe in a database or message broker like Kafka, and after some time again try to initiate. So these things like retry mechanism and storing the state of the transaction or the transaction itself in database or message broker, you can try if your compensating action is failing. Now moving further, understand which one is better, event based or orchestrator based. So in my point of view, if you have a simple use case involving 2 or 3 or 4 microservices, maximum 5, and your business is not very much complex, you can go for event-based approach, because in terms of complexity, it is simpler to implement and understand. If we talk about this advantage of event-based, as I mentioned earlier also, there could be chance of cyclic dependency that would further increase the complexity of the architecture, and it would be difficult to understand and maintain in case of failure. In case of orchestrator based approach, there is a central orchestrator. So in order to implement orchestrator, you can use Camunda finite state machine in Java or any other orchestrating tool. So this is adding overall complexity to the architecture. It may be an overhead also. You may require license if you are going for a good software. Advantage of orchestrator based approach is everything is passing through this orchestrator. So you can easily plug and play as a microservice, and it is just based on the command and apply mechanism. So it is easier to understand a complex architecture and maintain data consistency. And it is also easy to test if you have complex architecture of microservice and you are implementing it with orchestrator based approach. Now let's talk about advantage and disadvantage of Saga. So if we talk about advantage of using Saga, the point is very simple. It is used for maintaining of data consistency in case of distributed transaction in microservice architecture. This is one of the biggest advantage of using Saga design pattern. Another is, so when you're implementing the Saga design pattern, the microservices are not blocked by each other. So moving ahead, if we talk about disadvantage of using Saga, if you are using orchestrator based approach, you are increasing the complexity of the architecture. That could be an overhead. It is difficult to debug the transactions because those transactions is distributed in nature. Next disadvantage is you have to implement compensating action in case of failure of each of the transaction, and also you have to think what if the compensating action itself fails. So in order to summarize of this video, we have learned about why to use Saga, event-based approach and orchestration-based approach of Saga. What happens if any transaction fails in Saga, how to compensate if the compensating action itself is failing, advantage and disadvantages of Saga. So this was all about Saga design pattern.